everyone to today's ALASCA Tech-Talk, ALASCA Tech-Talk number 29. My name is Ariane. I am moderating this format that is being held or hosted by ALASCA once a month, where we come together to talk all things open source and cloud infrastructures. And yeah, it's great to see that we're a nice group of people today for Tech-Talk number 29 already. Also, please note, as always, this session is being recorded because we will upload this later on YouTube so that you can rewatch or share. Okay, on the agenda today, we will dive into today's Tech Talk in a minute, and we will have plenty of time for a discussion. Then we will look at some news and events as always, and then we will talk about the next Tech Talk that is going to take place in October. Okay, so for today's ALASCA Tech Talk, I am very happy to welcome Steve and Silvio from Cloud&Heat Technologies. Steve is the team lead of the team Kubernetes, and Silvio is a DevOps engineer in this team. And they will be talking about TAROOK. TAROOK is an ALASCA open source project, and it's for holistic lifecycle management of Kubernetes clusters on bare metal or OpenStack. And so this is very nice to get an update on this. And I think that's already it from my side. Nothing more to add. And I will give the stage to you guys, and you can start.
Okay, taking presenter rights.
Yes, you got them.
Okay, I'm ready. Yeah, okay, then let's start. My name is Steve, and that's my colleague Silvio, and we will talk about TAROOK, holistic lifecycle management tooling for Kubernetes clusters, for bare metal clusters or OpenStack clusters. We have a nice landing page, and you can scan the QR code if you want to. Looks pretty cool. I will give you some seconds to grab your phone. But I guess you can also do that in the YouTube video later. So yeah, we'll start with an overview. TAROOK is an autonomous project of the ALASCA Foundation since some weeks. It's a lifecycle management tool, as said, and it provides and operates customizable, highly available, and flexible Kubernetes clusters. It is officially CNCF certified since a few weeks, as certified Kubernetes distribution. So we are conform to all the requirements which must be met there. The deployed Kubernetes distribution is very opinionated through in some aspects, but it provides functionality beyond day one. It allows to maintain long-lived clusters. Actually, we maintain clusters for several years now, or which live for several years, and it works quite well. And compared to some offerings of prominent hyperscalers, we have some different philosophical approaches in some aspects. For example, we do consider nodes as mutable instead of immutable, and nodes are not just thrown away and rebuilt on Kubernetes upgrades or configuration changes, but we maintain them over a longer period, which is useful for bare metal clusters, and especially where provisioning node is not that simple. Yeah, some repository analytics. We have contributed or 59 authors contributed to the project so far. We have nearly 5,000 commits on our Dev branch and released 118 releases so far. We have a few issues open, 148. It's increasing and decreasing dynamically. But we already closed 600 or nearly 700. Currently, there's about 40 merge requests we are working on, and we got 1,700 merged so far. So it's a dynamic project. The main components are Nix since a few months, Ansible code, Bash code, and Terraform to provide EAS resources. And the project is hosted and maintained on GitLab and mirrored to GitHub, which was a requirement for the CNCF certification. Yeah, the history of TAROOK, because we promised that in the abstract of the talk. The project started as an internal Cloud&Heat proof of concept in mid-2019. In early 2020, we created the first productive cluster, which actually still lives. In the end of 2021, the LCM was published as part of YAOOK. It was previously known as YAOOK Kubernetes. And then we made some changes to the LCM. In summer 2023, we introduced HashiCorp Vault as a secrets backend. I will come back to that later. We refactored the whole code during the so-called core split and made the spaghetti code carbonara, I would say. And late 2024, we introduced Nix as a configuration language, which gives us a lot of benefits. And yeah, as said, the project got rebranded to TAROOK recently. The CNCF certification was acquired this year, and now is this Tech-Talk. Some selling points about TAROOK. It allows to deploy Kubernetes clusters on OpenStack or on bare metal. We can provide IPv4 only or IPv6 only or dual stack clusters. We use Nix as a configuration language, which is cool. It comes with an extendable monitoring stack with Prometheus, Grafana, and Thanos. It includes automated GPU and vGPU support. We are able to provide a root-based Ceph storage, either on a cloud or directly on bare metal. And as said, we use HashiCorp Vault as backend for the public key infrastructure and secrets management. And it's customizable due to hook points we implemented. And we are currently making it more customizable with introducing further hook points. This is the high-level cloud architecture of a typical cloud. TAROOK comes into place at several points. You got the hardware layer. I guess you can see my mouse pointer. Yeah, okay. We have the hardware level, so bare metal nodes, and these can be or should be Kubernetes control plane nodes and Kubernetes workers in modern environments. And then we can spawn with TAROOK a Kubernetes on top of these. And in this Kubernetes cluster, you can then, for example, install a YAOOK deployment, which gives you all the OpenStack stuff, Cinder, Glance, and so. So you got the OpenStack APIs, messaging queues, databases, Keystone, and stuff. And on top of this OpenStack cloud, you can then provision another Kubernetes cluster, which you can hand over to a third party. That's usually what Cloud&Heat does with our managed Kubernetes product. So we can spawn also on in a virtualized environment with VMs and virtualized networks and volumes and stuff. And then the third party can spawn workload on top of this Kubernetes cluster. What YAOOK does not offer, but is essential for an OpenStack environment, is a storage backend, where also TAROOK comes into place. We can deploy a Ceph cluster on some bare metal storage nodes, which this then can be used for OpenStack as backend to provide volumes to the virtualized workload running on top. Yeah, that's roughly that. The high-level cluster architecture of TAROOK is shown here. I will jump a bit back and forth. We have a glossary here. TAROOK has, or we made the Kubernetes API not available or accessible through the internet, but we use so-called front-end nodes, which are the entry point to the Kubernetes cluster and to deploy a WireGuard server. So the Kubernetes API is behind the VPN endpoint. And it also comes with NF tables for firewalling, automated, and Kubernetes and HA proxy to make the cluster highly available. We also have the control plane with the usual stuff: etcd, Kubernetes API server, Kubernetes controller manager. Sorry, my dog is sitting on my feet. Okay. And the usual Kubernetes worker, which also can be meta worker, so-called, so workers dedicated to a specific use case. For example, you can have monitoring nodes, which only host the monitoring stack, or storage nodes, which host the Ceph cluster, and then usual workers, GPU workers, or just some generic workers. That's the high-level overview. Below that Kubernetes cluster is the hardware infrastructure layer, and as said, this can be either a self-managed bare metal cluster, so you just install an OS and the Tarook only needs layer 3 access to a bunch of nodes, or you create the hardware infrastructure with an auto-controlled bare metal service as the AUK metal controller or something else, or this can also run on top of an OpenStack environment. So yeah, as said, the cluster is only accessible for administration via VPN tunnel. You can also connect it to another cluster for leveraging monitoring. And the external traffic, so ingress traffic, is also handled through the front-end nodes, so that the firewall routes and such can handle things. Yeah, this is basically what I just said. So we will skip that slide and we will come to the concepts of Tarook. And this is the high-level software abstraction. Tarook can, as said, provision the hardware infrastructure layer on OpenStack with the help of Terraform. And we evaluated also Proxmox. It's a bit transparent here. It's not production ready yet, but it will come soon. And after you got the necessary requirements, so you have a bunch of nodes which are connected via network, either virtualized or not, you can then other stages trigger, which we call the Kubernetes core and the Kubernetes supplements, and I will explain them later. And in between these runs, which are all Ansible plays, currently you can do some customization stuff. And yeah, I said the hardware infrastructure layer can also be managed on your own or via the AUK metal controller. The Kubernetes core, so-called, are actions, as said, mostly Ansible playbooks, which automate and allow the bootstrapping, preparation, configuration, and customization of nodes to fulfill the requirements for initializing mostly vanilla kubeadm-based Kubernetes cluster. As a container runtime, we use containerd, and it's dynamically configured for different use cases. For example, if you want to make use of GPU nodes, you have to do some containerd configuration, and Tarook takes care about all of that. If it detects a GPU, that the GPU is attached to the node. This is what the Kubernetes core does. The etcd pods are currently run as static pods on the control plane nodes, which is a common case for kubeadm clusters. The control plane itself is made highly available and load balanced with Kubernetes and HA proxy. So make use of these projects. And as said, the Kubernetes core also has the feature to prepare GPU nodes, which need some special care. Around the Kubernetes core, we do have the Kubernetes supplements, which also consists of Ansible playbooks currently. And what the Kubernetes core gives you, as said, is a very rudimentary vanilla kubeadm-based cluster without anything. So it's not functional yet because, for example, a network plugin is missing. And but it can be used to deploy the real basic Kubernetes cluster. And the supplements then supplement that, as said, or as the name suggests. and deploys or can deploy a lot of useful stuff. So for example, as said, network plugin, we use Calico, customized Calico setup, where the front-end nodes act as root reflectors to the internal nodes, so we don't mesh anything, or we mesh, but it's not a full mesh. It also comes with the volume snapshot controller, which can be used to create snapshots of volumes inside Kubernetes. If the cluster is spawned on OpenStack, TAROOK also takes care of the OpenStack integration, so the Cloud Controller Manager, the CSI plugin and stuff. If run on top of OpenStack, we also come with a self-developed load balancing solution, so-called CH Kubernetes LBAS, because each cloud provider has to develop his own solution for load balance services. So TAROOK also can provide load balancer services if you want to expose internal Kubernetes workload to the outside, that's necessary. We come with local path provisioning, local persistence volume static provisioning. We do maintain Ingress and Nginx controllers, everything automated, and further stuff. As said, we hold a monitoring stack, and that comes with Prometheus, Grafana, and Thanos. And if you as this is disabled by default, but if you enable it, all the other components are also configured to provide metrics, and dashboards are automatically created, which is quite cool. We can also provide FluxCD, a set, a Rook Ceph cluster, either running on bare metal, but also on top of OpenStack for development purposes, or to allow a user to use read-write many volumes. And another important component, which is often needed in productive environments, is the sort manager, and TAROOK also comes with that. Yeah, what TAROOK makes specific, or I don't know if unique, but just to a lot of, at least I don't know of other providers which leverage HashiCorp Vault as secrets backend. So in TAROOK, the Kubernetes PKI is not managed by kubeadm, which would normally be done, but via Vault instance, which is used as backend, such that the root CI key has not to be stored on the control plane nodes, but everything can be managed via Vault. The intermediate and leaf certificates are then derived directly from Vault instead of self-managed and self-signed. So it's possible to maintain a external root CA as well. Certificates for kubeconfigs, a lot of components and users obviously require kubeconfigs to interact with the Kubernetes API. And certificates for the kubeconfigs are also derived directly from Vault, and this allows fine granular configuration and access control. For admin users, we're encouraged to use short-lived kubeconfigs. For example, at Cloud&Heat, if we want to interact with a cluster, we dynamically generate a kubeconfig with admin privileges, which is only valid for 8 days. So the certificate is only valid for 8 days. And that reduces or improves security and reduces attack surface. Yeah, some components, for example, Thanos needs access to a S3 bucket and configuration for that. So passwords and secrets like S3 configuration are also stored inside the key value engine of Vault, and then have not to be pushed into a Git repo, or yeah, they are stored safe in a Vault instance. So you have to have a Vault instance, but if you spawn one, this can be used for multiple clusters and serves as central cluster isolated encrypted environment. For development setups, such that you don't have to create a Vault instance running somewhere, TAROOK allows you to run a Vault instance locally in a Linux container, so that you can start developing very quick. And another feature is also that nodes get scoped down access to the Vault instance, and this can be used for some use cases. For example, in TAROOK, the nodes there's a SSH engine involved and nodes that the SSH keys be signed by a common SSH certificate authority, such that you don't have to check the fingerprints of each node, but you can just say, I trust this certificate authority, and then you can connect to the node and you can be sure it's safe to connect. The SSH certificates are also short-lived and automatically renewed by a systemd timer, so it's automated setup that the certificates get renewed at certain points in time. What we also implemented, and what is not common in other Kubernetes distribution, is the automated root CA rotation. So CA certificate is valid for 10 years. Most clusters don't live for 10 years. But if you come to that point, you have to do a root CA rotation, which is not trivial. And we automated that and tested that, and it works quite well. Yeah, that was just to the, I would say, implementation specifics around the project, the code itself. We have release management. Our releases use semantic versioning, version 2. We do provide changelog release notes, which are created via Towncrier, which is an open source project, which is cool. We have a versionized documentation with the help of Sphinx multi-version. We have a hotfix and backport strategy, so releases are kept up to date. We maintain the latest 3 major and minor releases, and take care that you don't run into problems if you stay up to date with upstream. We also have a deprecation policy.
Steve,
yeah.
I at least still see the vault.
Okay.
Release management. No. Yes.
Okay. Sorry for that. I don't know. Yeah, we also have deprecation policy for features or configuration options we change or which change over time, and release migration scripts which make it easy to migrate from one Tarook release to another. For the documentation, we decided to use the Ataxis as documentation framework, which is cool. You can DuckDuckGo that. Basically, it comes in 4 categories: how-to guides, references, explanation, and tutorials. We additionally separate between users and developers, and that makes the structure of a documentation clear and helps finding information really quick. Yeah, that's it for my part. For now, I will hand the word over to Silvio.
Yeah, hello. Steve already mentioned a couple of times that we use Nix in Tarook for some purposes. And can you show the next slide? Yeah, here's a short time scale for what we use Nix and since when. We started out just doing optionally managing system dependencies. Since last year, we also built the CI image with Nix, and we work towards managing all dependencies first optionally, and since February this year, since version 9, we manage all dependencies with Nix. We also use it as a configuration language to type check and validate all options, and these are then rendered for Terraform and Ansible. And also we render our reference documentation with that. Plus we get an easy cluster initialization from Nix. Next slide, please. Yeah, the dependency management. So we have, we as Cloud&Heat, we manage several different clusters that are at different versions in different states at the same point in time. And what we wanted to achieve was to have a reproducible environment for all of them. So when someone in our team wants to access a cluster, they check out the repository of the cluster, and then automatically via dir-env, they get exactly the same environment with all the dependencies as all the others. So we can ensure that the cluster is accessible for everyone, but also that the behavior is the same. And additionally, we use Renovate to keep the versions up to date. So next slide, please. So you can see we have, like, Tarook has lots of dependencies, and they are still dependencies, but prior to V9, you had to ensure to install them all manually. And of course, everyone would have a different version, and now Nix handles all of that. The only thing you need is dir-env and Nix, and if you use a dev setup, then Docker for the Vault instance, or Podman, or just any container runtime. Next slide, please. So how does that work? We have three different directories in the repository, in the cluster repository. We have the config directory, we have the state directory. You don't see my mouse, but they are here, like in the right is the state, and down there's the inventory. And it works like that, that the user configures the default .nix file in the config directory. And then there is the flake.nix, which is basically the entry point for Nix. And that one pulls our Tarook module. It can pull custom modules. For example, we use it to configure all our employees that need to have access to clusters to get their WireGuard keys and so on. And then Nix renders the state files for Terraform and WireGuard, and also the inventory. And then Terraform uses those state files, does its thing to spawn the instances, and writes back to the state, from where Nix again gets the updated state and renders that into the inventory. And from there, Ansible can run and deploy Kubernetes. So let's have a very short introduction into Nix. Basically, Nix is a JSON with functions. As you see on the right, it looks very familiar. Just a couple of things to watch out here. The different attributes are separated by semicolons, and lists are separated by spaces instead of commas. Otherwise, it looks just like JSON, but you can, as shown here, and the attribute set c.foo, you can set nested attributes with a dot notation. And then, of course, there are functions. This one is a very simple function. It takes x as an input, as an argument, and adds 1. And of course, you can go arbitrarily complex with that. Next slide, please. So this is how we define the options that are available with Nix. We have simply define a description, have a type and a default, and we can also add an example. And then this is rendered into the documentation like that. Exactly. And of course, the values are then rendered into the Ansible. I would just skip the next slide as we are already over time. But I want to, can you skip to the Ginger one? 2 slides. Yes. I want to emphasize why this is such a good thing to have. Here you see a snippet of a Ginger templating that templates for a Rook Ceph cluster. And you see that we have a huge YAML file from where we see a snippet here. And then we start to template stuff into that. Each value we need to ensure to call that JSON. Then you see some indentation here that you really should not get wrong. Yeah, and in general, it's not a very good idea to template structured languages. So if we convert that to Nix, you see here we get a very much cleaner looking body. We can simply iterate over the nodes with for each and then set the name to the node name. And then for the devices, we can map simply the device name and the device config. So what that gives us is that we can feel more sure that that what is rendered is actually what we want to be rendered. So we get, before the step, we have a type checking, and then here we don't have to watch out for indentation. We don't have to watch out to get stuff converted from strings to other types, but the types are just there. And in general, if we already have a structured input, like Kubernetes can read YAML and JSON, then we should try to use a structured language to produce that input. Yeah, Nix even has some syntactic sugar to make this even more to make this even shorter. So yeah, I'd say let's go to the, yeah, I give back to Steve because we're already over time.
No, it's fine. We have like
we don't
6 more minutes, so it's all good.
Okay, yeah. We fit that we don't have enough content, but now we have too much. I prepared the screencast, which we skip now. I will give a short outlook to the near future. We want to extend and further automate the certificate management with Vault, and in the very soon future with OpenBAO, which is a fork of Vault, because there were some license changes on the HashiCorp side. We want to further make the configuration of Helm charts more flexible and safeguarded via Nix. As said, we are currently making the proxmox or spawning clusters in proxmox productive, and we want to switch to OpenTofu or Terranix instead of Terraform. So this is what should be happening in the near future, which is planned. In the more distant future, we want to implement an in-cluster signer in Rust, which can handle Kubernetes certificate signing requests and leverage it to the Vault backend. We want to package everything into a CLI tool called TAROOK Control as a side quest. We're currently working on that. We want to reduce the Ansible code, and after we introduce TAROOK Control, implement logic into that or configure nodes as far as possible with daemon sets. And currently evaluating how we could prepare nodes with NixOS, or want to evaluate that shortly. And in general, we want to improve synchronization and automation with the whole OOK stack. And in the even more distant future, it is planned to implement a TAROOK controller in Rust, which reconciles and manages multiple TAROOK clusters, and which is CAPI compatible as far as possible. So the TAROOK controller just runs a simple reconciliation loop and then prepares the TAROOK cluster to the needs. Here's a first draft of the architecture, how that could look. But as said, that's probably the more distant future. Yeah, that's it. Thanks for your attention. You can get in touch via mail, preferably via GitLab, or you can join our public meeting, which happens each week, the so-called shore leave. And we have a meta documentation, all information you need, you can find there. Yeah, thanks.
Thank you so much for this overview. Very interesting. Yeah, I wonder if there are any questions from the audience. If there are questions, you can raise your hand or write them in the chat. People are applauding, so that's a good sign. There don't seem to be any questions right now. So I think we're good. But yeah, I think a lot of people from the crowd will be at the ALASCA Summit as well. And as far as I know, you will be there with TAROOK as well. With a workshop, as far as I know. So yeah, that will be interesting as well. And also a good opportunity to ask questions and to get more in touch with TAROOK. So yeah, I think who's interested can join there too. Last chance for a question. Otherwise, thank you so much for this presentation. Then I will continue with some other news and events from our side. I'm getting back the screen share rights. Oh, there is something popping up in the chat. Oh yeah, Daniel Gerber's asking, maybe there's still time for the screencast. I think so. If you want to do this, maybe.
Yeah, but don't expect too much.
It's all fine.
That was really just to fill time in case we don't fill it with other content. Okay, can see my screen, I guess.
Yes.
Okay. So yeah, just recorded this morning how you would interact with it. TAROOK clusters. What I would do, or what typical users do, is log into Vault and then create a new kube config via a script we created or provide, the so-called Kubernetes login script. This gives you a short-lived kube config, and then you can access the cluster after spinning up the WireGuard tunnel. And as shown here, all the dependencies which are required for interaction with the cluster are stored in a Nix store inside the dir-env of the cluster repository. So kubecontrol is not one I installed on my system, but in the isolated cluster repository environment. And then I just go over the cluster configuration. This is how it looks. We have some nodes, all the config options, which set, yeah, some WireGuard peers. That's basically how a Nix file looks if someone hasn't seen that before. And I think there's not that much to that. Yeah, and then you can, for example, if you want to install something specific, you can do that fine scoped. We provide different playbooks. For example, this is what I do now, is install the ingress controller. It's already installed, so nothing will happen. But as you can see, you can, in a fine granular way, install stuff if Kubernetes already exists. And yeah, there's not that much to the screencast when I just jump over the Kubernetes environment with K8s. Yeah, so not that exciting. But that was the screencast I prepared.
Perfect. Thank you so much. What is the chat saying? Thank you. Thanks. It was cool. So yeah, that was worth showing. If there are no other comments or remarks or questions, let's wait a second. Okay, I think we're good to go. One more comment in the chat. Okay, Bruno just shared the IRC chat room. Thank you so much. So if you want to visit that, you can totally do that. And I will go back to sharing my screen. I hope this is full screen now.
No.
It's not?
No.
Oh, that is sad. Let me try now.
No.
That is very weird. Let me take a second. Otherwise, we will just leave it in the small version. Doesn't matter. Last try.
No.
No, but it's fine. It's
fine.
okay. I guess.
Perfect. Well, yeah, then we will move on to news and events. So first of all, again, you've all heard it. The ALASCA Summit is around the corner. It's like a few weeks left. We are in the middle of the final preparations. And if you want to join November 3rd and 4th in Dresden, we kindly ask you to register now because it also helps us with planning. And yeah, you've just heard we will have a Tarook workshop as well as other workshops, a lot of interesting keynotes and talks, as well as a panel discussion. So I think this will be a very, very cool get together with the whole ALASCA community. Then event-wise, just 2 days ago, the SCS Summit in Berlin took place. And of course, ALASCA was there too. And I know there are some people in the audience who were actually there. So if someone wants to give a little report, feel free to do so.
Okay, I'll give mine then. First of all, thanks so much, Steve and Silvio, for this great presentation. It was really nice. And yes, I'm just hopping on to give a little bit of a recap for everybody who maybe wasn't able to attend the SCS Summit. This week, it was on Wednesday in Berlin, and it was held under the motto standardization, collaboration, and continuity. And it really is through and through very fitting, that motto, because I think as a community, once again, we did realize that these three things really are essential for our success, and how relevant collaboration really is for us as a community if we want to keep driving forward those topics. And the continuity for me is always also very interesting, because in that context, meaning that we don't necessarily need to come up with many new things, many new technologies or new initiatives, because there really is already a great basis that we can continue building off of. And it was, again, a really, really nice event with some great technical talks, but also some more high-level talks and a great discussion on the Deutschland stack, which was also very interesting for me to hear those experts talking about that. And yeah, just from a personal standpoint and the whole community aspect of it all, I personally really enjoyed seeing many familiar faces, but also specifically seeing that overlap between the SCS community and the ALASCA community, and how that shows our joint interests and that we truly are really all working towards a very similar overall goal. And ALASCA was also very, very present at the SCS Summit, which was really nice for me to see, because it was mentioned many times by different people in different talks. The summit was mentioned many times. It was recommended by different people. And there was really a very clear interest visible in people towards ALASCA and the summit. And then we did also have a keynote speech given by Daniel, who not only works for ALASCA, we all know that, but he also is the deputy chairman of the board of directors at the OSBA. And it is always great to have that chance to represent ALASCA in that setting as well. And then last but not least, some of our members also received some of the first ever SCS certificates. like B1 Systems and Uhuru Tech. So congrats on that. Great achievement. And yeah, I think I'll wrap this up. It was really a really nice event. Thank you to the OSBA and SES for hosting and organizing. And I think, if I'm not mistaken, the next one is May 21st, 2026. But do correct me if I'm wrong. But in general, 10 out of 10, highly recommend.
Thank you for this lovely report. Is there anything anyone wants to add? I don't see the chat right now, unfortunately. So if there are any comments, please just speak up. Otherwise, I think we can move on.
I wrote in the chat that we were still seeing the Alaska Summit slide. I don't know. I think you had maybe pictures. I'm looking at.
Yes, I know. Thank you.
Yeah, the pictures.
Oh no! Oh, something is very off today. I'm so sorry.
Yeah, I think you just
let me try one more time because this is too sad. Does it work now?
Yeah, perfect.
Yes.
Yes. Okay. Okay. So this is the slide. I mean, the report was very vivid already, but here's the supporting slide with the photos. So yeah, thank you so much for mentioning that. Okay, so moving back to Tarook for a moment. I mean, Steve and Silvio, you already mentioned this. Tarook has received the Cloud Native Computing Foundation Managed Certified Kubernetes status, and I know this was quite some work and a long journey and a lot of effort from the community. I think, Maria, you wanted to add something to this because you've also been involved in this.
Yeah, I can say a few words, although to be honest, the only thing I did was to fill in the last form and send it to the Cloud Native Computer Foundation. So all the work was done by our colleagues like Silvio, Steve, and Daniel, who's also here, and many others who've been working on Tarook in the past. But just to say a few words, because I think this is a very important milestone for Tarook. It's something that was already started, I think, last year or even the year before. Then we had to stop it because of this Tarook splitting out of Yaook and so on. And now it's great that it's been achieved. It's something that it's very much aligned with the whole of Alaska's strategy to make sure that the projects are also embedded in the broader open source community. And with the certification now, well, it's approved that the Tarook is interoperable with other distributions that also have this certificate. It also ensures that it will stay up to date with latest Kubernetes versions and upgrades and so on. Well, and yep, it's for those of us who don't know much about how this process works, it's also very nice to see how the process is really transparent. So there's like some self-tests that you have to run, and everyone who wants to check that really this Tarook is still conformant to these tests can run these tests themselves. So yeah, also a very good sign of transparency and allows everyone to check this conformity. So yeah, something great, something that I think it's really good for the project. And yeah, congratulations to everyone that was involved in this process. Not me. I just did the form.
Okay, perfect. Thank you for that report. Yes, congratulations from my side as well. I know this has been a journey and it's a major milestone for the project. So very fitting for today's Tech Talk, actually. Okay, moving on. One last announcement is that we have a new Alaska member. Starke has been joining us. Starke is a company focused on open networking, and they have been active in the Alaska community for a while now. I think they've given a tech talk earlier this year. They're also a sponsor of the Alaska Summit, and I guess it was only natural for them to join the association as an official member, and we are really, really happy to have them on board. I don't think they are present here today. Otherwise, please speak up, maybe if you want to say something, but I don't think I saw anyone. But still, yeah, we are very happy that Starke is joining us. Other events from the community, I know the OSBA Connect is around the corner on November 13th in Berlin. So maybe keep that in mind. Other than that, are there any other news and events that anyone would like to share? Just speak up or drop it in the chat. Doesn't seem to be the case. Okay, then we are almost done. You know the drill, you know the ALASCA Tech Talks. I don't think I have a lot to say on this anymore, but if you want to submit a talk, we are now looking for speakers for 2026. Write us an email via hello@alaska.cloud or wherever you can grab us, just approach us. You can see all the past Tech Talks on YouTube to get a feel for what we are doing here. And if you have an interesting topic, just contact us and we can figure out if it matches this format. Last but not least, the next ALASCA Tech Talk is in October, on October 24th, 1 week earlier than usually due to a national holiday. We will be welcoming Christian Behren from 23 Technologies, who is also a longtime ALASCA member. The topic is being refined right now and will be coming very soon. So that is something to look forward to. I will stop my screen sharing and see if there is anything going on in the chat before I wrap this up. But no, it doesn't seem to be the case. So thank you again, Silvio and Steve, for taking the time today and for this great TAROOK introduction. We will see you at the ALASCA Summit and everyone else, hopefully as well. And with that, I wish everyone a beautiful weekend and a relaxed Friday, and we hope to see you next time. Bye, everyone.